Let's start. We are just on time. Just waiting for the door to be closed. Okay, it's happening. All right. Thanks for joining. We will in this session we will talk about briefly how we build our platform that processed, of course, 0, and now we for the last year's numbers, when you look at it, is a $500 billion we processed in the last year. So we want to explain how we designed for growth, and also while doing that we want to touch upon a couple of lessons we learned. Let's quickly start with the introduction.
Yeah, my name is Thinus Naude. I am the team lead of one of our platform engineering teams, focusing on sort of moving our platform onto more cloud-native technologies and changing our processes internally to scale better.
And my name is Efe. I'm also a team lead in platform engineering. I'm mostly focused on developer enablement, developer experience, and all the tooling around it. And well, mostly working with Adyen-wide cross-team projects. Let's start with the agenda. What are we going to cover today? Of course, we're going to do an introduction to Adyen. We will do a bit of like payments 101. I know in the audience probably some of you are not very familiar with how payments work. We will dive into Adyen Platform. So we're going to show the overview first, and then we want to focus on payment flow a bit. And later that we want to talk about our tech stack and the choices we have made. And last but not least, we're gonna talk about working at Adyen, like how it looks like, how we do things, and of course we will close with the challenges in the future.
Cool. Thanks. So maybe just to start out, who is Adyen? I think it's not too familiar in the Turkish market, but we are a Dutch financial technology platform, founded almost more than 10 years now ago, mainly focusing on the payment processing space, so accepting card payments and processing them amongst for merchants. Yeah, we process payments for many of these companies. Some of them you probably use today, or used before, or used in the past, or will use in the future. We have a global presence, and we provide a one-stop platform for merchants to integrate with us, and then we facilitate your financial ecosystem for you. But before we dive into specifics, maybe we can just go through how payments works, since it's a quite complicated process.
All right, as we mentioned, we're going to cover Payments 101. You can see some images, icons, and some arrows going around what they mean. I'm going to start with the merchant. Merchant is basically whoever integrates with Adyen. Let's say in this case, as for an example, we can see it's a Nike, and then there's the shopper, of course, easy ones. And then we have the issuer. Issuer means that it's basically the shopper's bank, like whoever gives you the credit card, this is your issuer that issues the card. And then you would see acquirer and scheme in this diagram. Schemes are, for example, like Visa, MasterCard, Amex. Those are the global networks that basically sets the rules. So they define how EMV specifics, for example, should look like, and then there is an acquirer. Acquirer is basically the acquiring bank, so it's getting the money on behalf of the merchant from the shopper. So you can explain it a bit in this way, as simple as possible. Of course, the challenge here is that if the shopper goes to Nike and they want to buy let's say a shoe, and then imagine even, let's make it a bit more complicated, you are abroad, you want to buy something in Amsterdam, you are from Turkey, you just want to spend a couple of euros, and the shopper goes and wants to try on the payment. How are we going to know? Shall we approve the payment or not? Because your bank, your issuing bank, actually knows how much limit you have, how much you can spend, and then this merchant is integrated with some company, let's say not in this case Adyen, some company that has a payment terminal, they have no idea about your limit, right? So in this case, a global communication should happen. We have to, as an acquirer, you have to ask the scheme, and the scheme goes to the issuing issuer, basically the issuing bank, and then gets an approval or not. That is the most complicated part of the payment. And then, of course, imagine you are Nike, you can't possibly go and integrate with all the possible acquirers in this world, right? But as Nike, of course, you want to sell your products globally. So instead of Nike doing this one by one, here comes the Adyen. Adyen takes the heavy lifting. We are specialized in payments, so we can take care of the complexity. We can do the connections in the world. And then basically for a Nike, it is one communication for their payments platform. That is the story.
Yeah, so what makes this landscape so complex, and why is companies like Adyen needed? Well, first of all, uptime is non-negotiable, right? Imagine you're at a shop and you want to pay something and it doesn't work, you will get frustrated and leave the shop and not buy something, right? So uptime is needed across the board for payments. You cannot be down. There's no, on Sunday night between 1 and 2 you can't shop. It's not a thing, right? It happens 24/7, globally, worldwide, everywhere, right? So that's technically quite complex to achieve. There's also some strict legislative and compliance requirements. As Efe mentioned, you have the schemes, MasterCard, Visa, setting lots of rules. You can do this, you can't do this, etc. As well as governments and countries setting specific rules. So for example, we are a bank in Europe, which gives us certain financial limits that we can operate within, but not in some countries in Africa, right? They have their own sets of rules and requirements that we have to adhere to and implement. Then, of course, on the technology side, it's quite complex. Like Efe mentioned, you have thousands of banks globally, right? It's impossible for everyone to integrate with them directly, so we have these levels of abstraction. And even those integrations that we do are sometimes very, very complex. They range from, for example, making an API call, very simple, to, in one instance, we are actually processing disputes over fax. So in 2022, we still have a class in our codebase called fax parser, where we process faxes to interpret the data. And that's where the legislation comes in, that that country and that scheme didn't actually catch up to the modern time. So we take that complexity for you and then abstract it away to make it easier. But maybe we can go over the platform at a glance.
Yes, enough sales pitch, huh? So we can go to a bit more about the platform. Of course, when you look at it, we offer many financial services, but we want to focus especially on the payment flow in this talk. But we want to throw some numbers at you as a start. We have more than 10 Postgres databases, which are over 100 terabytes. Big number. And then we have 12 data centers globally at the moment, still growing. We're going to add more, of course. We have more than 90K of CPUs running on those data centers. We have more than 500 developers globally. We have currently tech teams in US, Brazil, Singapore, Australia, Netherlands, and Spain. Well, main hub in Amsterdam. Of course, we want to mention that we are hiring. And when you look at the throughput, we process more than 80 million transactions a day. I hope it tells something about the scale.
Yeah, and I think an important part of our platform is that we own and operate all our own data centers, or not own, sorry, we rent a data center space from data center providers. And that's actually one of the core parts of our sort of way of thinking in terms of technology, is that we as a company want to be fully in control of everything. We want to be in control of the hardware and the software. So we get to choose, you know, what CPU we use. Do we want a bigger machine, smaller machines? You know, we are in control from that first point of contact that the payment hits the system. We're also very we don't like vendor lock-ins. We don't want to be tied to only using AWS services, as an example, right? also having our ability or managing our own data centers gives us that flexibility to use any provider that can rent us a rack or some space, and we can scale where our merchants are, which is quite nice as well. We also have the expertise for this internally, which many companies maybe don't have, but I think we have a really strong team building out those data centers for us, allowing us to scale exactly in the way that we need to scale. And it's also a nice sort of reliability thing, right? Because if your cloud provider is down, at least your payments is still up. So that's a really nice way of thinking about it. We don't want all your eggs to be in one basket. It is nice to have that separation of concern.
All right, let's get to the more and more technical stuff. So we would like to touch upon the payment flow architecture and then some decisions we made through it. We just wanted to put this complicated graph so that we can explain. So basically, there are a couple of ways, of course, to integrate with Adyen. As we mentioned, we have terminals, we have merchants directly doing API calls, we have hosted pages, so the shopper can basically just visit our website. We have the biggest separation in the case, well, is the external applications and internal applications. Why are we putting these? Because it's very important for us that we put the abstraction in between. So the edge services, as you can see here, is basically you have multiple ways to basically integrate with Adyen, and then you have separate applications for that also. We were thinking, I think, together with Thinus, like how can we call our architecture, and we came up with the distributed modular monolith. I mean, it's not as, it doesn't sound as fancy as microservices, but I mean, it's a practical decision that we made to keep it in way. And then, of course, as I mentioned, like the abstraction in between, we have many asynchronous parts in our platform that gives us the ability to basically scale exponentially. That's very important. That we kept it in that way. We will touch a bit upon it later. Of course, scalability is very important, as I mentioned, and then. Many components in this graph is basically built in-house. So we built our own RPC framework, we built our own web framework, we have our own caching solution, and then maybe lastly we also have our streaming solution. We will explain them a bit in the later.
Yeah, so from the previous diagram, you could see clearly there was two different parts, right? And we like to refer to these two separate parts of the payment flow as the synchronous part and the asynchronous part, right? And from a shopper's perspective, you as shoppers will mostly be concerned about the synchronous part, right? You go to a store, you pay for something, and then it's approved or declined, you leave, right? That's the part that is focusing on in this part of the diagram, right? So the basics of it is basically a request comes into our API. That request is transformed to a particular format that is expected in our internal applications, and those internal applications have the knowledge to actually translate it to the particular scheme that you're issuing, right? That you're connecting to, right? So if you have a Visa card or a MasterCard or some strange local scheme, the transformations all takes place in the internal layer. However, you as a merchant just integrated with this singular API that's very, very nice and convenient to use, while we take care of the complicated conversions, right? And as you can see here in this example, there's actually an IPsec VPN tunnel that we're opening to some scheme and acquirer, and here we might be sending some bytes over the wire, right? It depends on the schemes as to what transformation is needed. Like I said, in this case, it's sort of this over-the-wire bytes we're sending in some ISO standard. In other cases, it's an API call. It really depends, and that's what the logic takes here. During the synchronous flow, we might also do various other checks like risk or recurring payment or card tokenization or whatever. There's many things that can happen here. However, since you are at the store waiting to get your shoes or whatever, it should be as quick and as low latency as possible. So there's lots of optimizations in our platform to make sure that this part is as quick and efficient as possible, because we want you to get your merchandise. Once these requests are sent and the responses are returned to the edge layer, they are stored in a local Postgres database. So each of our edge services has a database that's local to it. So there's no network traffic when storing it, right? And then the response is returned. So once it's in this database, the synchronous flow is finished. We will get to the asynchronous part later.
All right, so far so good. The shopper already bought the shoes, and they just went home happily. And then here comes the asynchronous flow. What do we mean by that? Of course, whenever you approve or decline a transaction, that's not over yet, right? You have to do the settlement, you have to do the reporting, you have to do the reconciliation. There are a lot of further processing comes to the payment. That's where it happens, basically. From that local database, we have a queue processor, a Java application, picking up those payments and forwarding it to our accounting system. And when you look at our accounting system, we also have separate clusters, shards, as is known, and then that one is also horizontally scalable, so we can add more and more clusters when the traffic gets higher and higher. As we mentioned, we already reached more than 100 terabytes every single accounting cluster. Whenever we need more, let's say, horizontal scale, we can just add more and more to do it in this way. And it, as you can see, is completely decoupled from the sync flow, from the authorization flow. This gives also the external services an ability to scale completely individually. So you can basically see where you need the scale. You can decide, okay, I want to increase the level of, let's say, the applications externally or internally. It's completely separate.
Maybe focusing on this queue implementation we briefly mentioned. Basically, I just wanted to highlight here that this illustrates the pragmatic way that we like to work at Adyen. It's not a queue framework as such, but basically it's a Postgres table and a few Java classes. You have to implement a few methods and you have a queue available and ready to go. So we have this sort of used quite extensively in our company, where you can have very, very simple like class structure, but you get a really, really robust queuing mechanism in Postgres directly deployed, and this is, we will highlight a bit more how it works. So basically this is that same local database, the payments get stored there, and then we have these queues, basically just Java classes, right, which we start up to read from this database and send them wherever they need to be sent. These then correspond to the amount of shards in the database we have, or the amount of clusters we have, and we can scale them up as we need, right? It also has the nice benefit here that we could remove one cluster temporarily for some reason, and then the payment processing can still continue on other clusters and they're not impacted in that way. This setup actually gives you a lot of flexibility, and particularly important for us is the ordering guarantees, right? If you make a payment and someone does a refund, the refund can't be processed before the payment was processed, right? So we need that ordering, and then that's also tricky to do the synchronization of these queues on the global scale. And of course, it's a very fail-safe mechanism. So this local database gives you that sort of guarantee that, yeah, if the network is down, whatever, we can retry. If the backend is completely down, they can wait a little bit and we do it later. And that's really, really flexible in an environment where you can't have downtime, right? So this explains the asynchronous part of the application, but of course if you look at the right hand side of this diagram, you have some databases which are the shards or the clusters, but of course at the scale we operate at, it's not really possible to just do SQL queries on all these databases. So Efe will briefly take us over our event streaming framework and how we do sort of this streaming processing on these databases.
All right. Okay, we are talking about the journey of the payment, right? So we did the synchronous flow, we said yes or no, and everything was okay for the shopper. And then it comes to the accounting, we did the accounting, we did the all the settlement, reconciliation, all is good. But let's say you go to a back office and then you want to see your payments in one place. As Thinus mentions, it's not very feasible to query like 5, 6, whatever whatever databases you have. So we build our streaming framework, and then basically this framework is built in 2016, and then it's mimicking the Kafka behavior. But back then, when Kafka was a lot smaller, it was not giving us the requirement we had back then. That was, first of all, ordering of the stream events, and the second thing is exactly once delivery. It's very important for the payments that you can't really stream it twice. That would, that would basically create a lot of problems in your system. So that's why back then in 2016 we decided to build our own streaming. It's based on basically Postgres again. And then one thing about the producer part also is the serialization of events. When you look at the consumer, or our consumers, one single consumer is basically consuming more than 400 gigabytes of data daily. So you have to stream the events as small as possible. So that's why we came up with our custom serialization framework, where we say we create this complex payment object, we convert it to a JSON, we basically compress it, and then we also create a dictionary of the keys, so the object gets as small as possible, around 1 kilobytes. That is the let's say the strong side of the producer part. And when you look at the consumer, prefetching the events, so whenever you are consuming a certain batch of items, we already get the next batch. That was also built in the framework. And then of course, as you can see, we have multiple clusters, right? So it means that you have multiple partitions. You can basically consume them in a completely parallel way. That's the beauty of it, let's say. As we mentioned, we are using Postgres heavily, so maybe let's also have a look at the databases, like how we do it.
Yeah, so of course if you use Postgres as extensively as we do, we are quite good at hitting some limits in Postgres. I mean, you can imagine if you have databases of more than 100 terabytes, at some point you get to a situation where you can't Google the problems you're facing, which is also sometimes a bit fun. I will just quickly want to tell a story that about an issue we had a few years ago, I can't remember. But back then we were still running Postgres version 9.6, and in Postgres 9.6 the way the table vacuum works is a bit different than in Postgres 13, which is what we're running now, and there was some limits on database tables. So I don't know if you know, but the maximum table size limit in Postgres for a single table is 32 terabytes. We hit that limit one day. Very, very exciting, incident. But the important part here was we were luckily already looking at how to partition this table, and we were able to roll it out. So we fixed the problem. However, it's at this point of our talk where I just want to highlight that the architecture we talked about before, that tiering we have, that we can turn the front end the back end basically off, but the front end or the edge service are still processing. This saved us, because now you had a table that could not accept any more data. It was full. There's no more. You can't insert, you can't delete, you can't do anything. And because of the architecture that we had, we could just turn off that cluster. Nobody knew it was off. The payments were still being accepted while we fixed the issue and roll out the changes that I mentioned. So the architecture allowed us to sort of have this downtime without any downtime, and then there was some delayed reports potentially, but the payment processing side was still up and running, and nobody knew we had this huge issue we had to deal with, which is quite a nice thing to have in an architecture like ours.
Right, and then since we are talking about the decisions about the technology, we would like to also elaborate a bit like our approach to technology. As you have seen that we are talking about only Java, Postgres, very pure, let's say. We are not really a framework-heavy company, so we would like to give you like the principles of Adyen. We say like we build for today, so we solve the problems of our merchants. We really hate over-engineering. We don't want to do that. And when you look at the designing part, we have to always keep in mind that scale is enormous. So you have to keep up with that. Always important to design for the future. Boring is good. We like it. It maybe doesn't sound very interesting, but it's very reliable. And as a financial company, we are good with that. It gives us the stability. That's important. But even if you do everything great, things will break. As we mentioned, that you would hit the limit of a Postgres database table. Yeah, good luck. I mean, you have to really keep in mind that things can go bad, and you have to always keep it in mind that yeah, you have to always think about it. Like, things will break.
So a nice thing that we'd like to always highlight is sort of if you look at the InfoQ technology curve, right? Adyen is usually on the right-hand side. We don't really want to be on the left-hand side because that is usually where there's lots of exploration going on, lots of issues going on, lots of bug fixes going in, lots of experimentation, right? Which is what you would expect from more newer technologies. We like to play it a bit more safe on the right-hand side to adopt technologies when it makes sense and when it gives us a clear benefit that is not too unpredictable, right? We don't want to be in a situation where at 3 a.m. we're investigating an issue, we need to go to GitHub, look at the issue, look at the code, it's super complicated. We would rather just wait a few years, months, depending on what the tool or technology is that we're looking at, and have it be a bit more stable, that we can implement it very reliably and sort of trusting that we don't have to risk any unnecessary issues. And we have a nice blog article on this on our blog about it as well, where we dub it as "We are ruthless about our stack." It's not a game, it's not just there to sort of play around with, it's people's money, and we need to be serious about that. And choosing stable technologies really helps with that. Of course, if you only stay on the far right of this diagram, you risk sort of falling behind, you can't do recruitment, people don't want to work with older technologies, fair enough. But there's a fine balance between these two, and I think we, as a company, need to find that balance, and that's what we're doing every day. We will now quickly just go over sort of one of these things that we want to highlight that we are adopting to facilitate that, and Efe will go over that now.
Yeah, we are talking about the decisions, right? And it's always nice to document things. So that's where we use the tech radar. In our internal tech radar, we are calling it internal because we are not yet publicly sharing it, but there are plans, of course, but we document our decisions. Well, it's a bit blurry, but you can see that basically, especially as a new starter, you can go to our tech radar, you can have a look at it, why we made a decision or not. We also we adopted the architecture decision records, so we document our decisions, like why we want to do it, how we are going to use it, what are the, let's say, restrictions, what is the limits. I think that's very important for us, that we document these decisions, and then we can basically just publicly share within the company, let's say, and that everybody knows why we made that decision. It's not some ivory tower, some group of architects, let's say, making a decision and you don't even know why they do it that way. We completely want to avoid that. Yeah, and then one of the challenges, again, we will quickly go over this one, is of course the scaling internally, which means that how we work together. As we said, like, we are growing exponentially also with the people. So let's have a look at how it goes.
Yeah, so basically, more on the technical side, we use a Monorepo for our code base. We have a lot of lines of code, we have lots of Java modules, and we really like the Monorepo approach. We will go into a bit more detail later. On the platform, like we mentioned before, we mainly use Java and Python for the data side of things. And we do weekly releases of the platform following a release train deployment model.
When you quickly look at the Monorepo, why are we doing this? Of course, yeah, the shared libraries, and especially when you need to, let's say, keep track of the versions of different applications, it becomes a really crazy mess. I mean, we completely avoid that by using a Monorepo. You can basically see what the others are doing. You can, if you want to see how one of the frameworks actually work, you can just go read the code. You can change it even. If you see a bug, please do it. I mean, we implemented code ownership, but it doesn't mean that you cannot touch the code. You can definitely see a problem and then fix it. We share the entire repository together, and then of course, yeah, basically. Whenever you make a change, especially when you make a big change, everything goes in one commit. That's very, very powerful. I think we are very proud of this approach and how we implemented it.
Yeah. Another important thing that we like to always highlight from a cultural or a team perspective is there's always the interview question I get that, do you do Scrum, do you do this or whatever. So we don't do any particular flavor, we just call it whatever we do at Adyen, right? So whatever we do is each team decides for themselves. So some teams want to do Scrum, some teams want to do Excel spreadsheets, some teams want to do whatever. So it's very much in the culture of the company for a team to be empowered to make the choices they want, even in the way they work, right? And that is sort of really, really nice in that sense that you can if you have a really good idea, you want to try out Kanban, right? Just do it. There's no one to ask. There's no single board saying, oh, everyone is going to do that, you know? And that's pretty nice. Well, we're almost at the end of the talk, but we will just quickly touch on sort of what we're going to do next and as a company and as a technical organization. Like, what is it going to look like?
All right. I mentioned you, right? The numbers are good, so we're going to give you this is a publicly shared from our earnings call, the graph, like the growth, it shows the growth of the company. As we mentioned, like last year we processed more than $500 billion, and then you can see that year to year it's basically 70% increase on our volume, which means also as a higher load on our systems. That's the scale, that's the growth that we are trying to keep up with, and then of course we have to plan for the next challenges, like how we can improve the current situation.
Yeah, so basically for us in the technical organization, these are just some of the problems we are thinking about and solving right now or working towards. So of course, faster releases. I mentioned we do weekly releases with a sort of a release train model. We would like to speed that up. So we're looking at sort of seeing how can we within our sort of way of working make that better, make that faster. Like I mentioned, we are working more on sort of moving to cloud native technologies. That does not mean we're going to deploy in the cloud, it just means we're going to adopt the tooling aligned with that effort. There's also lots of work on our big data platforms, right? That could be a whole talk on its own. And as Efe mentioned, with this growth we're seeing, right, we will be rolling out to new regions, and we need to have a really, really strong focus on scalability, right? We are hitting sort of limits where, you know, a change, one line Java change, that thing is executed millions of times a second. These things have lots of impact in the day-to-day, and we need to think about it and sort of plan for that going forward. And of course, scaling people. We need to keep up with the growth of the company, and we need developers for that, obviously.
All right, you have seen our booth. This is what's going to happen. Of course, we are finalizing our talk, and then we're going to do a raffle at 2:50. Please drop by our booth, sign up for that. There's one shiny Nintendo Switch we brought from Amsterdam. We would like to give it to one of you. Please come and just have a chat with us.
Yeah, and that was our talk. We also have some time for questions, so any questions?